Good morning students. Today we discuss how we represent irrational number. Representing irrational number on number lines. Now consider two examples. Here root 2, root 3, root 5, root 7. These are the irrational number and we have to represent this on a number line. So first draw a number line. First we draw here a number line. Suppose this is our number line. Here we draw a number line. On this number line, we represent here. Suppose this is point number 0, that is origin. Here we consider distance, some distance 1 unit, 2 unit, 3 unit. This is suppose 1, 2, 3, and this is 4. 4 units. Okay, that is 4 centimeter or 4 units. Now here this is our 0, that is origin. Here we draw here minus 1, 1, 2, 3, 4 and etc. Now we have to represent here root 2. How root 2 is obtained? By using Pythagoras theorem. If we consider Pythagoras theorem, we know that if here we consider side 1, 1 which having perpendicular, that is the 1, 1. If sides are 1 centimeter, 1 centimeter, then the length of this hypotenuse is 1 square plus 1 square is equal to here 1 square is 1, that is 1 plus 1, that is 2, and this hypotenuse is equal to then here root 2, that is under root 2 by using the Pythagoras theorem. So we here apply this law, that is the Pythagoras theorem on a number line. Here we consider a distance 0 to 1 unit. Now we draw here perpendicular distance 1 unit. Here from 1 we draw here perpendicular distance, this is 90, and here we draw a perpendicular distance. Okay. Now we draw here perpendicular distance. We draw here perpendicular. This is 90-degree angle, and we draw here 1 unit length. We take first 1 unit length in our compass. Take 1 unit length. Okay. This is 1 unit length. We can also put from this. This is 1 unit length, and we draw here a arc in this manner. This is 1 unit length. Okay. This is nothing but the 1 unit. The distance is 1 unit. This distance is 1 unit, or we can say 1 centimeter here. Now here this total distance from O to A. Here means suppose this is point A, and if we draw this line segment OA, if we draw this line segment OA, the length of this OA is nothing but the root 2. Using this is nothing but the root 2. The length of this line is root 2. And here if we put this distance in our compass and we draw arc from this and this length, this is the root 2. We can represent root 2 at the point. Here it is root 2. In this manner we can represent root 2 on a number line. If we want to check it or verify it, now using Pythagoras theorem, here if we consider this is point B, this is point B. Now here AB square plus OB square, AB square plus OB square is equal to AO square, AO square. Using Pythagoras theorem, we use here Pythagoras theorem. If we put the values 1 square plus 1 square, 1 square plus 1 square is equal to AO square. Here 1 square is 1 plus 1, that is AO square, and we can write here AO square is equal to 2. Means it implies that AO is equal to root 2. Means this distance AO is root 2. In this manner we can also verify this distance is root 2 and we represent root 2 on this number line. Similarly, we can also draw root 3 on number line, root 5 on number line. Now how we can draw root 5 on number line? If we want to draw root 5, for root 5 we consider the length, this length 2 units, 2 square that is 4 and 1 square that is 1, 4 plus 1 5 means we have to draw here perpendicular at a 2 unit distance. If we draw perpendicular, here perpendicular on this 2 unit length, this is perpendicular, we draw here in this manner, we draw here perpendicular and this is our perpendicular. Now here we put again distance 1 unit, in a compass and we draw here R, this is 1 unit R, 1 unit, okay, this is 1 unit R. And now if we join this point, suppose this is point B, and if we join this point O to B, we get the distance root 5 in our scale or in our compass. This is nothing but the distance is root 5, this is 1 unit. Now here take this distance OB in compass, this is distance root 5 and represent on number line. We can represent it in this manner on number line, This distance is nothing but the root 5 distance. This is root 5 distance. Okay, we can represent in this manner root 5 on number line, root 2 on number line. Also we can represent root 3 on number line, or we can represent root 7 on number line by using the Pythagoras theorem, the concept of Pythagoras theorem. If we want to prove or verify this distance is root 5 or not, then we consider this triangle O, this suppose point C, O, B, C, in triangle OBC, here hypotenuse square means OB square is equal to distance OC square plus BC square. So here we put the values. OB square remain as it is, OC is nothing but the 2 square plus 1 square. 2 square is 4, that is OB square is equal to 4 plus 1, OB square is equal to 5 and OB is equal to, by taking square root, OB is equal to root 5. Distance OB is equal to root 5, and in this manner we can verify also this distance is root 5 or not. In this manner you can represent irrational numbers on number lines. It may be root 2, it may be root 3, it may be root 5, it may be root 7 or it may be root 11. You can draw or you can represent in this manner on a number line. Okay, so now you represent this root 5 on number line, we can represent. So remaining term, that is root 3 and root 7, this is homework for you. You represent this root 3 and root 7 on a number line. Okay.